Dear students, in this class we will derive the second law of refraction from the Fermat's principle. That is, derivation of second law of refraction from Fermat's principle. So we can say it is the second law of refraction, or we can also say it is nothing but the Snell's law. So we can say it is the second law of refraction, or in other words, it is the derivation of Snell's law from the Fermat's principle. So in this class, we are going to derive the Snell's law from Fermat's principle. Right? We know basically what is Snell's law. What is Snell's law? We know that mu1 into sin I equals to mu2 into sin r. Mu1 sin I equals to mu2 sin r. What is mu1? Refractive index of the first medium into sin I equals to mu2. What is mu2? Refractive index of the second medium into sin r. So this is the Snell's law, right? So this Snell's law we are going to derive from the help of what is known as the Fermat's principle, right? So for that, what we have here is, now this is the diagram. So look at this diagram. So in this diagram, you can see xy is the boundary. XY is the boundary which separates two media. This is one media, this is other media. So XY is the boundary which separates the two media. The refractive index of this media is mu1. The refractive index of this media is mu2. Right? So XY is the boundary which separates two media of refractive indices mu1 and mu2. We have an incident ray AO. AO is the incident ray which makes an angle of I with respect to the normal ON. ON is the normal, AO is the incident ray. So the incident ray AO makes an angle of I with respect to the normal. What is the OB? OB is the refracted ray. So this refracted ray is making an angle of R with respect to the normal. So this is the refracted ray. R is the angle of refraction, I is the angle of incidence. Right? Then the distance from A, we draw a perpendicular from A to axis xy. So the distance AP is taken as small a. The distance BQ is taken as small b. Right? So the distance from here to here is taken as small a. Distance from here to here is taken as small b. Then the distance from P to Q. Distance from P to Q is taken as d. The distance from P to O is taken as x. If this is x and this is the d, then the distance OQ is going to be what? It's going to be d minus x. Right? So with these basic things, we are going to derive the second law of refraction, or what is known as Snell's law. Right? So for that, what we say here from figure, PO is x. Distance from here to here is x. PQ is a d. Distance from here to here it is a d. OQ is a d minus x. It is distance OQ is a d minus x. And then distance AO. AO is taken as what? Root of a square plus x square. How? This is distance x. This is distance A. The triangle APO is a right angle triangle. So the distance AO is going to be the hypotenuse. It is going to be hypotenuse. So this is going to be the square of this plus this. A square plus x square. Therefore we say AO is equal to square root of a square plus x square. Right? Then OB. What is OB? This is OB. This distance OB is taken as square root of b square plus d minus x bracket square. How? Distance from here to here is taken as b. Distance from here to here is taken as d minus x. Again, the triangle BQO. The triangle BQO is a right angle triangle. Right? If this is right angle triangle, this distance is going to be what? It's going to be hypotenuse. It's going to be hypotenuse. So it's going to be square of this plus square of this. Right? That is b square plus d minus x whole bracket square. Therefore, the distance OB is taken as a square root of b square plus d minus x whole bracket square. Right? Then, so we are calculating here what is known as the optical path. What is the optical path? We know that the optical path is nothing but the optical path is equal to mu into d. Optical path is mu into d. That is the distance traveled by the ray of light in a given medium into the refractive index of that medium. Mu into d gives us the optical path, right? So here what is the optical path? The ray is traveling from A to O and it is undergoing refraction and traveling towards OB. So the distance AOB, the distance AO plus OB, AO plus OB is going to be the optical path, right? So therefore we say the optical path is given as L equals to, we are denoting optical path by symbol L. So L equals to mu1 into AO. Why mu1 into AO? The ray is traveling a distance AO in this medium of what is the refractive index? Of the refractive index mu1. So mu1 is the refractive index of this medium. Therefore we say as per the optical path it is mu into d, right? So therefore mu1 into AO, mu1 into AO plus it is undergoing refraction along OB. But what is the refractive index of this medium? It is mu2. So we take it as mu2, that is, this is going to be mu2. It's going to be mu2 into OB. So the optical path AOB is going to be what? mu1 into AO plus mu2 into OB. That is mu1 into AO plus mu2 into OB. Right? But what is the AO? We know AO is root of a square plus x square. So it's going to be mu1 into root of a square plus x square. What is the OB? OB is given by root of b square plus d minus x whole bracket square. So it is going to be what? mu2 into root of b square plus d minus x whole bracket square. So this gives us the optical path. Optical path, that is the distance covered by the ray of light in the medium of mu1 and of medium mu2. So this is going to be the optical path. We call it as equation number 1. Right? Now we are going to differentiate this equation. We are going to differentiate this equation. You know, as per the Fermat's principle, we know that whenever a ray of light travels from one point to the other point, the time taken by that ray of light is always going to be either minimum or maximum or stationary. That is, whenever a ray of light travels from one point to the other point, compared to all other paths, the time taken is going to be either minimum or maximum or stationary. Or in other words, the path taken is going to be either minimum or maximum or stationary. Right? So whether it is a maximum time or it is a minimum time or it is a stationary time, all of them are going to be some constant values. It's going to be a constant value. So if we differentiate a constant, right? If we differentiate a constant, we are going to get 0 because we know that differentiation of a constant is 0. Since L is a constant, since what is that? Optical path L is a constant. That is, L is either going to be minimum, which is going to be a constant. L is going to be either maximum, which is going to be a constant. L is going to be either stationary, which is again a constant. Therefore, dl by dx is going to be equals to 0. It's going to be 0. So here you can see the point A and point B are fixed. Point A is fixed at a height of A, point B is fixed at a height of B. So point A and B are fixed. Whereas this position, point O can change. This can change this. The ray instead of falling here, it will fall here, undergo refraction. It will fall here and undergo refraction. Means what? O can change its position. If O changes its position, what it means? The value of x can change. The value of x can change as O changes. Whereas the point A is fixed at a height of A, the point B is fixed at a height of B. Right? So therefore we say the differentiation of dl by dx is going to be 0. Because why it is 0? Because L is a constant. L is a constant. So therefore dl by dx is going to be equals to 0. Means what? We are going to differentiate this equation with respect to x and we equate it to 0 and we simplify it. Once we simplify it, we get the final conclusion, that is we are going to get the Snell's law. Right? How? We will understand now. So let's differentiate equation number 1 with respect to x. What is that? So dl by dx. So differentiation of this first term is going to be mu1 into this a square plus x square can be taken as a square plus x square raised to n. That is a square plus x square raised to half. So d by dx of x raised to n. What is that? D by dx of x raised to n is going to be nx raised to n minus 1. Right? So differentiation of this term is going to go on. Keep the first term as it is. That is mu1 into is going to go on 1 by 2 into a square plus x square raised to 1 by 2 minus 1 is going to be minus 1 by 2 into differentiation of a square is going to be 0, differentiation of x square is going to be 2x, right? Plus second term differentiation, keep this term as it is, mu2 as it is. This can be taken as what? B square plus b minus x square whole raised to half. Or in other words, it is going to be mu2 into 1 by 2 into this term, that is b square plus b minus x whole bracket square raised to minus 1 by 2, right? Into differentiation of this term b minus x square. What is that? D square plus x square minus 2dx, right? So that is going to be differentiation of this is going to be minus 2 into d minus x. That is differentiation of d square plus x square plus minus 2dx. D square differentiation is going to be 0. X square differentiation is going to be 2x. So minus 2dx differentiation is going to be minus 2d. That can be taken as minus 2 into d minus x. So if we simplify this, these 2 and these 2 get cancelled with each other, right? These 2 and these 2 get cancelled with each other, right? Then what we are left with? mu1. You take this term to the denominator. It is going to be what? If you take the denominator, it is going to be a square plus x square. What is the a square plus x square raised to half? That is nothing but AO. Or if you take to the denominator, it is going to be what? mu1 divided by square root of a square plus x square. Similarly, here we are left with what? mu2. Take it to the denominator. It is going to be what? mu2 divided by square root of b square plus b minus x square. Right? So after simplifying this, what we get is mu1 into x. What is x? This x. mu1 into x. This is equal to the denominator. So mu1 into x divided by square root of a square plus x square. Minus, from here what minus? Plus into minus. So we get minus mu2 into d minus x, mu2 into d minus x, mu2 to d minus x. This is equal to the denominator, square root of b square plus d minus x square. All this is equal to 0 because dl by dx is equal to 0, right? Then transferring to the other side. So what we get? mu1 into x divided by this term as it is equals to, this is taken to the other side, mu2 into d minus x divided by root of b square plus d minus x square, right? So this is equation number 2. Now, what is this x divided by square root of a square plus x square? That is, look at the triangle APO. APO is a right angle triangle. If this is angle I, angle of incidence, this is also going to be angle I. That is alternate angles, right? So if this is the right angle triangle, if this is the angle I, so this is going to be the opposite side. This is going to be the hypotenuse. This is the opposite side. This is the hypotenuse. So this is x. What is this distance AO? It is nothing but AO is, this is root of a square plus x square. So this distance divided by this distance opposite by hypotenuse is going to be what? Sin I. Because in general what is sin theta? Opposite by hypotenuse. So therefore this is opposite side. This is hypotenuse. So x divided by root of a square plus x square is going to be what? This is going to be sin I. So mu1 into sin I. This is equals to, this is mu2 as it is. What is b minus x divided by root of b square plus b minus x whole bracket square? That is, if we take a triangle BQO, again triangle BQO is a right angle triangle, right? So if this is angle R, this is also going to be angle R, that is alternate angles, right? So if this is angle R, this is going to be the opposite side. This is going to be the hypotenuse, right? So what is this distance? OQ, that is b minus x. What is this distance? OB, that is root of b square plus b minus x square. Therefore, opposite divided by hypotenuse is going to be what? This is going to be again sin R. It's equal to the angle in this case is R. So therefore, this distance is going to be sin R. So it is replaced by sin R. So what we got? Mu1 into sin I equals to mu2 into sin R. What is this? This is nothing but the Snell's law. This is nothing but the Snell's law. What is Snell's law? Mu1 into sin I. What is mu1? Refractive index of the first media into sin I. What is I? Angle of incidence equals to mu2. What is mu2? The refractive index of the second media into sin R. What is R? Angle of refraction. So we derived the second law of refraction or the Snell's law by applying the Fermat's principle, right? Or in other words, this can be expressed as sin I by sin R. By taking it here, sin I by sin R equals to mu2 divided by mu1. mu2 by mu1. One more form of Snell's law, right? So here, what is media? The first media is going to be air media. If it's an air media, so mu1 is going to be what? It's going to be 1. Refractive index of air is 1. So mu1 is going to be 1. Then this mu2 can be taken as mu. That is, the ray of light is traveling from air media to a medium of refractive index mu. So mu1 is going to be 1. mu2 is going to be mu. Therefore, you can say sin I by sin R equals to mu. Sin I by sin R equals to mu. One more form of Snell's law, right? So this is how one can derive the second law of refraction or the Snell's law from the Fermat's principle, right? So what all we did here? We calculated basically the optical path. And we know that the distance traveled is going to be either minimum or maximum or stationary as per the Fermat's principle. So we differentiated L with respect to x and we came it to 0, and by simplifying differentiation and by simplifying we get the final expression of Snell's law, right? So this is how one can derive the second law of refraction or the Snell's law from the Fermat's principle. I think we'll stop at this point. In the next class, we'll derive one more derivation. Till then, you take care. Bye bye.